just a quick long multiplication recap. Now this is just to go over column addition. It kind of shows you step by step, column multiplication, and this is the most standard method. The reason I like to just talk about it is because I think it belays quite nicely, or it shows the understanding. So if we go through, if I was to write this out, well, I've set it up in this style here. So 4, 2, 3 over or times by 2, 1, 1. With multiplication, it doesn't matter the order. You can have whichever one on the top or the bottom you like. You'll see that changes for division. So I actually tend to put the larger number on top, but that's entirely up to you. We go through one by one, so you can see it's highlighted here, and we multiply each number in turn by all the numbers above it. So we do 1 times 3, which is 3, 1 times 20, which is 20, and 1 times 400, which is 400. Now notice, I didn't say 1 times 3, 1 times 2, 1 times 4. I said 1 times 3, 1 times 20, 1 times 400. And that makes sense because, of course, 1 times 20 is 20, which is why I put that 2 in the tens column, because it's really important to always be thinking about this. That we've got here the hundreds column, the tens column, and the units column. So when I did 1 times 400, I wrote 4 in the hundreds column. Now that's obvious to start with, but let's think now on the next step, when I'm multiplying by this one here, why we suddenly move over one space. Because I think understanding why we move over one space will help you to remember to do it. And another method I've seen is people just automatically put in a 0. But again, I think it's quite important we understand why we do that. So let me show you. So this 1, it's not really a 1, is it? It's in the tens column. So that 1 is actually a 10. So now, if I was to do 10 times 3, I get 30. And that's where I'm writing this 3, because that's not a 3, it's a 30, which is why it's going in the tens column. And that is the clue as to why it moves over one space. So again, you can just fill in a 0. But I think understanding that you're actually doing the sum 10 times 3, and 10 times 3 gives you 30, is really valuable. And there is your answer. So if we carry on, we now do 10 times 20, and that actually gives me 200. So that's why I'm writing the 200 here in the 200s column, in the hundreds column. And finally, I'm doing 10 times 4,000, 10 times 400, spoilers, which gives 4,000, which is why I've written the 4 in the 4,000s column. So that's why you get this sort of magic effect of them moving over one each time, because you're actually timesing by a large number, and that number is 10 times larger, so it shifts everything 1 unit of 10 to the side, moving it up a column. And so again, the pattern continues. So you can see here we shifted over 1, and again, I know lots of people like to have the 0, and actually I do too. I like to include the 0, just because it shows very nicely how we add them up. In this one, because we're now doing this 2, remember that is not a 2, what is it? It's a 200. If I was to write it out, it's 200. And that's actually another way of remembering the fact that, look, there's 2 zeros in the 200. So if I wanted to, I could add 2 zeros and it will always be the same. And then it's that 200 times 3. And 200 times 3 gives 600, which is why we're writing a 6 in the hundreds column. And then, of course, 6, we have then 200 times 20, which is 4,000. And then we have 200 times 400, which is 80,000, which is why we get the number we have, which is 84,600. And now finally we've got all our numbers, we can add them up. And again, in this one here, 3 plus 0 plus 0, because again, I would recommend drawing the zeros out when you do this, but 3 plus 0 plus 0 is 3, 2 plus 3 is 5, 4 plus 2 plus 6 is 12, carry the 1, 4 plus 4 plus the 1 that we carried across is 9, and then 8. So 89,253 is the final answer. But I think just bearing in mind and actually saying to myself when I'm doing the sum, 10 times 3 is 30, so I put it in the 30 column, the tens column, because it's 3 lots of 10, will just mean you're more likely, or you're much less likely to forget. And so I really like that, and that's how I would go about doing this style of long multiplication. The other way of doing it, and I like this equally much, is what's called the lattice method. It's also colloquially called the Chinese multiplication because it's what they actually teach and do in China. The way you do this method, again, same results, but just a slightly easier way. It's a bit more, bit more rote. We just kind of follow the instructions and do it, and it works. And it's not so much about understanding why, but it just works. Is to do the following. So you're going to draw a box for each number. Let me just show you what I mean. So here, I'm going to have 5, 4, and 6. I'm going to divide each of these into the columns. And here I'm going to have 2, 3, 1. This is the kind of method that if you've got books that have squares in them, to use those squares. I know in your maths jotter book, for example, you have squares. So you make a square for each thing, and I must say my squares aren't perfect. I would try really hard to make sure that my squares line up really nicely and look a bit more square. So actually, let's see if I can just square that off a little bit. That's a bit better. So that's step one. That's actually probably, I think, the hardest part of the whole method. Then we divide each square in half diagonally. And the diagonals need to be going away from the side the two numbers are written on. And then once you've done this, you just extend out the side a bit further a line. And now you're fully set up. All you need to do now is multiply each of the numbers on either side of the box. So I mean, for example, here you've got 6 times 2, so that will go in this box here, and 6 times 2 is 12. The tens, the 1 of 12 goes in here. The units, the 2, goes here. So 6 times 3 will go in this box, so that's 18. 6 times 1 doesn't have any tens, so it's 0 tens and 6 units. And that's how you fill out the boxes. And it doesn't matter the order, so I could do 5 and 3 for 15, then 4 times 3 for 12, and then 5 times 1, which is 0 and 5, 4 times 1, which is 0 and 4. What's nice is you'll get these patterns of, 1 times tables and so on and so forth, and 3 times tables, which can make it quite easy to actually check that your multiplication is correct. So here we've got 2 times 6. Next up, we need to do 2 times 4. That's going to be 0 and 8. And 2 times 5, which is 10, so 1 and 0. And now we've populated our box. All we're going to do now is add up down these diagonal columns. And once we've done that, we'll have our answer. Again, I wouldn't draw these arrows, that's just for us learning today, but these are the diagonal columns we're going to add up along. So let me show you how it works. I always reckon you have to always start adding down here. So 6 is the only one currently, so we have 6. Then we have 4 plus 8. Now that makes 12, so we're going to have to carry the 1, so carry the 1 and write down the 2. So I tend to write it in here. So there's a 1 and 2. Oops, sorry, put it in the right place. So carry the 1 into the one above and 2. Then I've got 2 plus 2 plus 1 is 5. Plus the 5 is 10, but plus the 1 we carried makes that an 11. So we will do again, we can carry the 1 and write a 1. And now we've got, some people also like to write the ones they carry down here. That don't mind where you record it. So we've got 1 plus 8 plus 1 is 10, plus 5 is 15, plus the 1 is 16. So again, show you that you can carry the 1 here and write 6. And then you've got 1 plus 1, which is 2, and then finally just the 1. And now what you do is you read the number in this direction. So the number is 1, 2, 6, 1, 2, 6, and that is your answer. And if you're not sure, it's always a good idea if you're ever doing this at home and practicing, you can have a little calculator ready to check. So 5, 4, 6 times 2, 3, 1 equals 126, 126,126. So it works. And what's lovely about this method is if you are not as confident with the maths, it separates it into smaller pieces because you're only ever doing really multiplications and then some addition. So you're doing multiplications of single digit numbers and then adding them. So I do quite like this method and I do recommend it. What's particularly cool about this method, I'm going to show you this as well, and this is why I teach it, because it's really valuable with decimal multiplication. Now we're not actually getting onto this yet, but I'm going to just show you anyway because I think it's quite cool. If I had a really hard sum like 5.46 times 2.31, this method works exactly the same way. All you need to do is put the decimals in the position that they are on the question, so between the 5 and the 4, and between the 2 and the 3. And now, I'll do it in purple, you follow the decimals along the lines to where they meet. So you follow this one down, wiggle, 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 and you follow this one across, and until you find the diagonal line that they meet. And now you follow that diagonal down, like this, and the answer to 5.46 times 2.31 is just putting the decimal here. And that is the answer. So if you had a really horrible multiplication, 5.46 times 2.31, you can get the answer exactly as easily as if you'd done it the other way. And again, if you want to get a little trusty calculator ready, so 5.46 times 2.31, I don't know if I can show you on the screen, it'll be back to front. Ooh, but there's my answer, 12.6126. So that's why I love this method, and that's why I think it's really cool. And so I'll save this one. If there's ever a difficult one or ever a decimal multiplication, I tend to use the lattice method. Okay, so I'm not going to suggest you copy that one down. I'm going to actually remove the decimals just to show you the basic one at least, the more basic one. But I suggest if you like that method, you think it's cool, I would copy it out. Just remember, what things that could people go wrong. Make sure that doesn't look like a 10. You want that to realize that's a 1 that you've carried over. But yeah, I would suggest copying it down and having a go, and maybe on the next page, try both methods and see which one you feel. I always recommend with maths, try out new methods and then decide what your preferred method is. And also just to show you, the reason this one does work as well, obviously the decimals currently are at the end, so 5.46 point and then 0.0 and then 2.31.0. So if I was to put the decimals in at the end, they would just match up, wiggle, 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 wiggle. They'd sort of match up here, and so the decimals would be the end, which it is. So it does actually work, that rule of following the decimals, even on this question, which is really cool. So again, pause it here, copy it down, and then I'm going to give you a bit of time to just look through these questions. Again, these are currently set out for the long multiplication column method. But again, if you're going to write these in your book, these aren't from any book, they just need a spare bit of paper, you're more than welcome to try the lattice method and obviously check your answers, because the answers will be the same if you've done it correctly for whatever method you've used. So guys, I suggest pause the video here, have a go. If you're a bit more of a competent mathematician, if you felt like you really got it last week, why not try my new method? Because I've showed it's a really useful one to learn for decimals. If you're not sure, maybe try one of each and then pick your favourite, or pick whichever one works and stick with that for the rest of the questions. Anyway, off you go. Pause the video here and come back when you're ready for some answers. Okay, guys. So here are the answers. And the working out for the column multiplication, again, I haven't done the working out here for the other one just because it's the slightly less common, I suppose. Most people in schools, I find, still are using this method, the column multiplication, although more and more are using the lattice method because it is a very good method. So mark your answers and see how you did. Again, I recommend with maths, it is a skill, and skills you improve by practice. It's not something that you just necessarily know, but if you do 100 multiplication questions, by the end, you'll be really, really good at it. And you'll know what method is. And again, if you take time to really think through tens times hundreds equals what, it does become a lot easier, a lot clearer. Right, that was a little recap, revision.